Aging is often framed as a slow unraveling, a decline in skin elasticity, joint mobility, memory, or endurance. But beneath all these symptoms is a much more fundamental shift, a gradual breakdown in cellular energy metabolism. As we age, our cells lose their ability to efficiently produce and manage energy, leading to a domino effect of dysfunction across tissues and organs. This isn't just a side effect of aging, it's a major driver of it. And that's why metabolism, particularly the pathways that regulate energy sensing and production, matters more than ever. At the center of this story is ADP, the molecule that fuels nearly every cellular function. From muscle contraction to DNA repair to detoxification, your body's health depends on a steady and responsive energy supply. But with age, mitochondria, the organelles that generate ADP, become damaged, inefficient, and fewer in number. As a result, energy production slows down, oxidative stress increases, and the cell starts cutting corners on repair and maintenance. In a sense, the body ages because it simply doesn't have enough energy to keep itself in top condition. This energy shortfall doesn't just cause fatigue. It weakens immune responses, impairs brain function, slows wound healing, and creates an environment where chronic inflammation and metabolic diseases can take root. When energy is scarce, cells also lose their ability to respond flexibly to stress. They become more vulnerable to damage, and once they hit a certain threshold, many slip into senescence, a state of permanent dysfunction that accelerates tissue degeneration. Fortunately, our cells are equipped with energy sensors like AMP-activated protein kinase, AMPK, that monitor energy status and adapt cellular behavior accordingly. AMPK is often described as the fuel gauge of the cell. When energy levels drop, whether from fasting, exercise, or mitochondrial strain, AMPK kicks in and signals the body to switch into conservation mode. It suppresses energy-intensive processes like growth and reproduction, and instead activates pathways that clean up cellular waste, improve insulin sensitivity, and enhance mitochondrial health. In this way, AMPK is one of the body's key anti-aging mechanisms. It's the system that tells the cell, things are tight, focus on survival. And that shift toward maintenance over growth is essential for longevity. In animal models, activation of AMPK has been linked to extended lifespan and protection against diseases like cancer, Alzheimer's, and type 2 diabetes. It helps cells keep their internal environment balanced, resilient, and metabolically efficient even in the face of age-related stressors. But in modern life, AMPK doesn't get activated nearly as often as it should. Most people eat too frequently, move too little, and rarely engage in the kind of metabolic stress that tells the cell to step up its energy game. Over time, this contributes to a chronic low-grade overactivation of mTOR, another energy pathway that promotes growth and storage. While useful during youth, mTOR's dominance in aging cells leads to excess inflammation, fat accumulation, and reduced cellular repair. The result? Faster decline. The key, then, is to restore the natural rhythm between AMPK and mTOR, and that means reintroducing metabolic signals that tell the body to prioritize energy efficiency and resilience. Fasting, caloric restriction, exercise, and even certain plant compounds like caffeine or polyphenol have all been shown to reactivate AMPK. These interventions help cells relearn how to function in low-energy conditions, which paradoxically makes them more robust in the long run. This isn't about burning more calories, it's about using energy smarter. In a healthy, youthful body, metabolism is flexible, adaptive, and responsive to changes in environment or demand. That flexibility fades with age, unless we deliberately challenge it. Keeping AMPK active isn't just a metabolic detail, it's a strategy for maintaining the cellular power supply that keeps everything else running. In the end, aging isn't just about time, it's about energy. And the sooner we shift focus from symptoms to metabolism, the better we can understand and potentially slow the aging process itself.